So good evening, everyone. As we said, we are living in a time of challenges, faced with a climate emergency that is forcing us to rethink the way we live, consume, and produce. In this context, innovation and science are our most precious allies in forging a sustainable future. The Technion, with its pioneering spirit and tradition of excellence in research and innovation, is at the forefront of this quest for sustainable solutions. Technion researchers are implementing innovative solutions to try and reverse our planet's gloomy prognosis. Their work focuses in particular on the use of natural resources and on rebalancing the Earth's carbon cycle. At the Technion, research into the key sectors of sustainability spans energy, transport, health, agriculture, food, and materials. Tonight, we are very honored to welcome brilliant minds and visionaries who are leading the charge in this crucial battle for our planet. Allow me to introduce our distinguished speakers. First of all, we are delighted to welcome Sandra Sancier-Sultan, senior partner at McKinsey & Company, who will be moderating our roundtable with her deep expertise in business transformation and innovation. Sandra will guide our discussions this evening with insight and acuity. Professor Avner Rothschild, Director of the Sustainability Frontier at the Technion and co-founder of H2 Pro. Professor Rothschild is a pioneer in the field of renewable energy, specifically in the production of green hydrogen, which is essential to our energy transition. We also welcome Professor Ilan Marek, Director of the Resnik Sustainability Center for Catalysis. His innovative work in catalysis is crucial to developing greener and more efficient chemical processes, a pillar of tomorrow's sustainability industry. Dr. Charlotte Vogt, winner of the EuroTech Future Award, is with us as well. Her groundbreaking research into the catalysis of carbon dioxide hydrogenation is opening up new ways of combating climate change. Professor Philippe Drobinski, Director of Research at the CNRS and Professor at the École Polytechnique, where he heads the Interdisciplinary Energy for Climate Center. His expertise in climate science and renewable energies is essential to understanding and acting in our energy system. Finally, Mr. Olivier Roland, Global Director Strategic Initiatives, Research and Innovation at L'Oréal for the Future and Green Sciences. Mr. Roland brings a unique perspective on sustainable innovation in the beauty industry and beyond, illustrating how large companies can be drivers of positive change. And finally, renewed paleoclimatologist Jean Jouzel, whose studies on climate change remind us of the urgency and importance of our actions today to preserve our tomorrow. For each of you, I will refrain from detailing the impressive list of your prestigious awards. So tonight we will dive into deep and stimulating discussions on how scientific research is guiding sustainable innovation, exploring cross-cutting technologies and strategies to reduce our ecological footprint. I'd like to thank you all for attending this evening, and I look forward to the enriching discussion that follows. I'd like to hand over to our moderator, Sandra Sancier-Sultan, to launch our roundtable discussions. Thank you, Sandra.
Thank you, Valérie, for this introduction. We have a pretty impressive group of esteemed panelists, and we are all very impatient to learn from them. So I'll suggest we dive immediately into the topic. Can I start with you, Avner? And you'll excuse me, I'm not from the teaching environment, so I'm going to call each of you by your first name, and I hope you'll excuse me. So Avner, you lead the Technion Sustainability Frontier. When we prepared for that roundtable, you shared with us how you build this around a few strong convictions on what it would take for us to successfully move towards a future that is sustainable both on the climate and on the biodiversity fronts. Can you tell us a bit more about your ambition and the construct that you've chosen?
Sure. So, thank you, Sandra. Thank you, Valerie, for the introduction. It's a great pleasure to sit here in this esteemed panel of friends and colleagues from France and Israel. With your permission, before we start, I'd like to spend one moment remembering that 135 of our hostages are still in Gaza. And although we celebrate 100 years of Technion, I think no celebration in Israel can be complete until the safe return back to Israel. With that in mind, I'd like to go on to the program and talk about the sustainability. I made 2 slides, and
yes.
if they can be, okay, great. So first slide is kind of general introduction to sustainability, and I think it's important because it's kind of explained the mindset that has led us at Technion to create the sustainability frontier. So basically and very, very fundamentally, sustainability is the art of living in a world of limited resources. And I think that's something that us, mankind, has overlooked for the past few centuries. And the result of this is very fast depleting and consuming of the limited resources of planet Earth at a rate that far exceeds the rate of regeneration of these resources. And the consequences of this behavior is that the capacity of the world, planet Earth, to support our living here is reaching close to its final resources. And therefore, we must change our way of life in order to make sure that we can continue live on this planet in the next centuries and in the next millennia. So that's the first thing. The second thing is, sustainability is the art of how we make these transformational changes to secure our future here on this planet. And it is composed of basically 3 main components that show the multi-scale of the challenge. And these are environment, social, and economic challenges. And sustainability is at the crossroad of all 3 of these components. And we have to take into account each and every one of them and the mutual interactions in order to make a sustainable future. Now, there are bad and good drivers towards sustainability, environmental impact. Unfortunately, the bad ones are us. And basically they comprise of population growth and affluence growth. So, the world population grow at the rate of 1.2% per year. The affluence grow at the rate of 2.3% per year. And, we consume, and all of our consumption turns out into CO2 emissions and other products that fight against sustainability. Now, the good factors are basically part of the economy and technology. The part of the economy is the energy intensity of our affluence. So how much energy we consume, and that is decreasing in a rate of about 2% per year. And there is another one is the technology factor, that is how much CO2 we produce in producing energy, and that is also declining at the rate of about 0.3%. These numbers are average over the past 10 years. In the end, we're still at a positive number, so the rate of CO2 emission continue to grow at a rate of about 1.2, 1.1% per year. And we are close to finishing our carbon budget. And once we do that, and that is expected to be within this decade, we are no longer within the safe boundaries of the 1.5%. And as was mentioned before by Professor Jean Gouzel, that lead us to a far more devastating impact on our future. So with this in mind, I'd like to move to the second slide, please. So these things have guided us in the design of the sustainability frontier, which, as was mentioned by our president, Professor Uri Sivan, is one of two frontiers of research and education in the Technion. But actually, the sustainability frontier goes beyond research and education, because we understand that this is a multidimensional problem, I just mentioned this, that requires also social and economic players to come in. So our frontier relies on basically 4 pillars, and these are research, education, stewardship, and outreach. So to the obvious research and education, we had the stewardship and outreach. Stewardship is, we know that we have to educate our students, and not only our students, basically the entire population, to change the lifestyle into a sustainable lifestyle. And this is education. And as every parent here knows, education starts by way of example. And this is our way of example of educating our people to think in a sustainable manner. And this is important because our role is first and foremost, and I believe Uri will agree to that, is to generate leadership. So that is the part of generating leadership, both at the Technion and worldwide. And the fourth one is outreach, because we want to go out of the Technion and eventually influence our local community and the entire world. So these are the 4 pillars on which the sustainability frontier is built upon. And basically, as a science and technology university, we are good in technology. And that is the core of the sustainability frontier. And, we want to focus on creating new technology, new ideas, innovative ideas that would support the technology to make our world sustainable. We've seen in the previous slide that this technological improvement only increases in a very slow rate of 0.3% per year. And I believe there is also opportunity here that we can accelerate the rate of technology improvement and the wide-scale adaptation. And that is our main focus. But we go beyond that, and we want to increase knowledge. Increasing knowledge is extremely important, not only as scientists, but also to create the knowledge to support decision-making. And I just want to give one example to those of you who may not know. Last decade, there was eventually a very poor decision made in the United States to support biofuel by corn. And in the end, we now know that that decision turned out to have a negative effect on carbon emission. I mean, increasing carbon emission relative to the gasoline that this bioethanol replaced. So we need to create knowledge to support the right action to adapt and implement new technologies toward the sustainable world. And last but not least, we need to increase engagement. In the end, sustainability is something that involves each and every one of us, and the 7.8 or 8 billion people in the planet has to change our lifestyle. And that requires engagement, and that is also something in our mind. So these are the pillars of the sustainability frontier, and just very, very briefly what it is. So Technion already has a lot of activities related to these goals, both in research, in education, stewardship, and outreach. But so far, we lack coordination between these different efforts, and we understand that now is time to coordinate between them in order to achieve greater goals and really address the grand challenges that we're facing. Some of the research centers that we have over 12 research centers. I just want to mention 2 of the new ones that we are adding in the last couple of years. One of them is the Resnick Sustainability Center of Catalysis, represented here by 2 of my friends. And another new center, research center that supports sustainability in campus is the Sustainable Protein Research Center. And last, I want to just address my personal thinking about this. So as a scientist, I was fortunate to be part of important discoveries and exciting discoveries. But for me, by far and large, the greatest contribution that I have made, and I hope will continue to grow, is transforming this innovation into technology. It's still in the making, so I cannot really conclude this part, but I can tell you that one of our most impactful research in my group deal with a new way of creating green hydrogen by electrolyzing water. And based on this process that we developed, we found a startup company called H2 Pro about 5 years ago, more than 5 years ago. And the way that this company is made, I can tell you, is much more challenging, but also much more impactful and hopefully much more rewarding than any scientific or academic work that I've ever done. And I hope that the sustainability frontier, the Technion and other universities will have more and more new technologies coming out of academic research. I think that is crucial to supporting sustainable world. Thank you.
Thank you, Avner. You'll see that the theme of interdisciplinary research, as well as the theme of how do we take that research and we bring it to the real world, is common among the panelists. Maybe I'll turn to you, Philippe. You share Avner's view that finding solutions will require multidisciplinary approaches, and you created the Energy for Climate Center. Can you just tell us what's similar, what's different to what was described of Technion?
Do you hear me? Yeah. So first, I'm a climate scientist working in the same institute as Jean Jouzel. And I bifurcated from, let's say, pure climate science about 20 years ago, because I felt that climate urgency pushed me to go from the diagnostics to the action, finding solutions. So I first started to teach about renewable energies, and in 2015 I decided to move to try to gather at the École Polytechnique, and Jacques Biot, former president of the École Polytechnique, is there and definitely supported my initiative to bring together many labs so that we can address the systemic complexity of the energy transition. And so 10 labs say, okay, so we're going to do some interdisciplinary research. And I said, okay, we're not going to do research as business as usual. Okay, we're going to demonstrate that research can be deployed in the field. And so 4 years later, I founded the Energy for Climate Center. So the keyword is interdisciplinary, because it's an interdisciplinary center. It gathers about 30 labs, so about 200 people coming from human sciences, from chemistry, and I'm glad also there is one of the leading scientists in Energy for Climate Center. I will talk about that later. And so yes, we need interdisciplinary research to make sustainability innovation a success by co-building narratives that favor socio-technical feasibility. That was said, it's not pure, let's say, tech, it's also humanities, so that our technologies, innovation can be accepted and deployed. So we have a very large disciplines, a very large number of disciplines from geophysics, which is not often the case. Geophysics is not widely spread, so sometimes it's good to have us also on board. But also, of course, well, chemistry, physics, pure physics, management, economics, also applied maths. So everything that we need to innovate in terms of energy transition. And the second aspect, and that's the slide which is shown here, And probably, once again, because I'm a climate scientist, very aware of the climate urgencies, I say, okay, we're going to do research, but we're going to demonstrate very quickly that we're able to deploy in the field solutions. So here we created what we call the E4C. E4C stands for Energy for Climate Living Lab. So we deploy a number of solutions on the campus. The solutions are deployed on buildings where people are living. They're not contributing to the research. Okay, they're just families and so on and so forth. And so we develop a large variety of, let's say, demonstrators. So if we go from one, so we have 2 electric smart building, one combining electric and thermal smart building, which is 4. So the 2 electric smart buildings are 1 and 6. In 2, we're developing a carbon capture and utilization demonstrator, and I saw Cédric Ta in the audience, who is the leading scientist for this project. In 3, we have an agrivoltaic farm, because we want to address the nexus water, energy, food, which is key, and especially I'm a specialist of the Mediterranean context, and we know that in the Mediterranean this is particularly a challenge. And in 5, to address adaptation, climate adaptation of cities, we try to evaluate smart garden solution as a possibility to mitigate, let's say, warming in cities. So this is a unique research approach to accelerate solution development, but it's also a unique immersive training experiment for students. So we have a problem of offer and demand. So we have too many demands for internships, for projects from students, because they can work, they can do their research or their project in a full-scale demonstrator, so touching, I would say, the energy transition in the real world. And finally, because we are deploying in a campus where many people work with, which are not part of the academic staff, we can work on raising awareness and also address the key question of social acceptability of our solutions. And I think I will end with this.
Thank you. I'll turn to you, Ilan. You lead the RESNIC Sustainability Center for Catalysis. Can you share with us what is it you're trying to do with the center, and maybe also tell us why this is such an important field for where we need to better understand, where we need to innovate, and why is it so important for the transition?
Okay, thank you. So I'm going to just follow on what Uri said previously, that the DNA of a technion to bring paradigm shift in science, discovery, and in society. And this is exactly what this center is trying to do. So what we want to achieve in this center is a complete paradigm shift in science, but also for society. So what are we planning to do? What we are planning to do is to have a place in which we are going to bring all the brightest mind of Technion, but not only of Technion, in a single space to work together. So we are planning to have faculty members which will be from chemistry, from biology, from chemical engineering, from material science engineering, from physics, from electrical engineering, from civil engineering, from electrical engineering, to bring all of these scientists to a common place and to work together to answer problems of sustainability through the angle of catalysis. And this is something that we can do only if we have a good trigger to bring all of these people working in their own department to come into a single space. And the idea we had initially was very simple. How to bring all of these people, how to bring a scientist outside of his office is very demanding. It's a very high energy activations to bring someone outside of his office. And the idea was to have equipment that none of us can have independently. So in this center, we will have something like $20 million of equipment that will be open to everyone to do better science in the field of catalysis. And this is the trigger, and this is the beginning of the story. Now that we have this type of equipment, people will come to this center. So this can bring new level of discovery, new level of sciences in the field of sustainability with, again, through the angle of catalysis. Now, how can it change also the society? Not only the outcome can change the society, but the way we are going to do research will change the society. Because not only we are going to use the brain power of Technion in a single space, but we are also going to have new faculty members. And in this type of new faculty members, I'm not going to go into all the details, but it's not classical new faculty members working in a specific place. We'll have an incubator. So we are going to have an incubator to help young scientists to be better until to a certain stage where they will go back to their own department. And so this incubator we will have 8 new faculty members. But the beauty and the originality of this center is that all of them are going to work together from different fields. All the fields I told you before, they will be coming from this field and working together. So which means that all of them will not have a single lab, they will have all the labs. What do I mean by this? We will have, let's say, 200 square meters of homogeneous catalysis, 200 square meters of heterogeneous lab, 150 square meters of lab for biocatalysis, 100 square meters of lab for AI, and so on and so forth. And a new faculty member will be coming, and he will be using everything. So it's not that I have my lab, which is this square, but it means according to my need, according to my collaboration I'm going to develop, I can use this part of the lab, or this one, or this one, or this one. So in fact, it's a space which will be open to everyone. And it's a complete different way of doing science. We want to merge expertise. And this is exactly the whole is always greater than the sum of its parts. We want to bring knowledge to a level that none of us can do independently. So it will not be a single researcher, it will be a group of researchers trying to answer these important problems. So we will have lab space. We will develop new catalytic processes to answer all of these issues of sustainability. But because we have this lab space, we also want to answer problems of industry. Up to now, I'm working in the field for more than 30 years. When an industry is coming to me, I am answering problems on the whiteboard, and the industry goes back in his own home, and they're doing whatever they want to do. Now we want to change also this concept. When an industry will be coming to us, we are going not only to help, not only with the single faculty member, but with a group of faculty members. So many of us are going to help the industry. So we are going to merge expertise, but we are also going to provide a product because we have lab space. And to provide a product is a completely different process than what academia did up to now. So we will have a lab space to answer problems of industry. And because we have also this lab space, we are going also to try to help researchers to bring discovery to a level which will be high enough to attract investors. Issues of sustainability are not like computer science. In computer science, you can create ways, if you are very clever, in a couple of years, and you have ways. In sustainability, you need labs. And investors are really afraid to invest money if they don't know what will be the outcome in 10 years from the beginning. So what we can do, because we have the lab space, we can take a discovery of researchers from this institute, from our Technion or from this center, and to bring it to a level high enough to be attractive to investors and to create startups. And of course, we know at Technion how to create startups at the end, but we have a gap between the discovery and the attractiveness to investors in this particular field. And in this center, we can do it. So this is exactly what Turi told you a little bit before. It's a paradigm shift in how we do research, and it's also a paradigm shift in society. We want to bring scientists all together, to work together, and to bring answers. And if several of us are sitting in the same room for a couple of hours, something new is coming out of it. And this is exactly what we want to achieve in this center.
So this is not only extremely inspiring, but this is also extremely effective. So Charlotte, tell us about the move from the theory to the reality. We've heard from Uri, we've heard from Avner about the importance for Technion to foster business application from research through the creation of startups. If I'm not mistaken, you oversaw the spin-off, a recent spin-off, which is a great example of how a team with merged expertise can invent a fully different process, carbon negative. Truly fascinating. Can you tell us a bit more about what is that spin-off and what has been the journey to make it a reality?
Yeah, for sure. Are we hearing me correctly? Yeah, okay, good. So I work in the field of catalysis, and for those of you who are maybe not so familiar with this term, I always say it's like a chemical magic wand. Essentially, you're speeding up a chemical reaction and making things happen with less energy and faster overall, less energy because of it. And it's estimated that about a third of the world's global gross domestic product is affected by catalysis already. Most of that is coming from fossil fuels, right? And most of the processes that we're applying right now, we've been doing for decades, and we've been doing them exactly the same way for decades, for hundreds or 100 years already in some cases. And we also develop catalytic processes very much in the same way. So if we want to come up with something new, let's say we want to make something out of carbon dioxide, we want to make jet fuel with it, we have to try thousands of catalysts typically, instead of thinking, okay, I'll make this recipe exactly, and rationally design essentially a process. And so this is a big aim at the center, and maybe just to give a real life example of the multidisciplinarity, which was discussed a few times already today. When I started my lab at the Technion 3 years ago, time flies. I was lucky enough to grab students from really a lot of different faculties, so from medicine, from physics, computer science, really all kinds of different brains. And we spent the beginning, as you have a lot of time in the beginning of your tenure, we spent a lot of time talking and discussing and brainstorming. And my students came with ideas, which if I would have, had just my own little backpack of knowledge to be relying on, never would have came up with. And in a few months, we were able to come up with a process which is combining water treatment, seawater treatment, and carbon capture. And currently, we have developed currently we think that we are the most energy effective way to capture carbon, which is also really largely scalable. And I think this is a great example of this multidisciplinarity, and also of the really fruitful environment at the Technion, which I love to work at. That the side-by-side availability of doing really excellent fundamental science, and then also bringing it to fruition. So this is, I would say it's a good example in real life of these principles.
Is it already a spin-off? Is it already
We are currently in formation. We're currently in our first funding round. It's a little bit more difficult right now to get funded in Israel, but we're on it. Yeah.
If there are people interested in the room, you know who to go to afterwards. Staying on the topic of transforming scientific insights into a business reality that does enable and accelerate the transition to a sustainable future, Olivier, your company L'Oréal is rethinking its collaboration with nature through its Green Sciences program. I believe you wanted to share a video about it first, or do you want to introduce it?
Thanks, Sandra. Well, maybe I can introduce it before showing the video. So L'Oréal has been for decades in the past for a more sustainable business and company. And today we have this program called L'Oréal for the Future, which is our corporate sustainability program covering 2021 to 2030. The objective of this program, when you think about it, is really to make it right. And simply put, it's about how we can transform all of our operation, whether those are under our control or on the upstream or downstream part of our value chain, in order to be, by 2030, in a position we can operate within the safe space of the planetary boundaries. For those of you who do not know about this framework, it has been developed by the Stockholm Resilience Center, and it is basically science-based, and it defines 9 boundaries with threshold. And if we go beyond this threshold, the mankind will not be able to continue to develop, while at the same time the environment is self-regulating. And so this is a really ambitious program that has been declined in 26 objectives, social objectives as well as environmental objectives related to natural resources, related to water, biodiversity, and climate change. And in order to deploy it, we did design a green sciences program with this research and innovation, and I'd like to share with you a movie in this respect.
Can you see us? We're right here. Can you hear us? Listen closely. We are everywhere. A thrilling superpower. A hidden tool that will revolutionize beauty, because beauty is in our nature. We are many. From one, we are all. Infinitely connected. We are soil, fungi, leaves, flowers. We are bacteria, living organisms. From the smallest cell to the largest ecosystems. We are the primordial brain, the original World Wide Web. As we break down what has ended, we feed and begin again. Our resources travel and are even recycled. The original sustainability champions. We create clean elements, working in cycles. We infuse intelligent connections. We inspire radical performance, optimizing rather than maximizing. We are the living forces of nature. Can you see us now?
We, at L'Oréal Research and Innovation, believe in nature's incredible powers. Our search for unequal performance stems from nature and is always underlined by the preservation of its resources. It is our greatest source of inspiration as we focus on the forces of nature, bacteria, algae, and fungi. It is our past, present, and future. It is our mission to work with nature and protect it. The green sciences, the science of beauty.
Moved by nature.
Olivier, if you allow me, when we prepared for that for the roundtable, you said something that resonated very much with me. You said that the challenge in front of us goes beyond innovation. It is about transforming innovation at scale, at cost, and locally. Just wanted to say that we at McKinsey share very much that conviction. We have analyzed 12 categories of climate technologies that could potentially reduce as much as 90% of total man-made GHG emissions if deployed at scale. These technologies exist, but at the same time, they will need not only to be proven technically, but also they need to be commercially viable. And when we look at the maturity of these 12 technologies, you know all of them, huh? Only 10% today are commercially competitive. So we would be talking about, for example, onshore wind with connection to grid. This is commercially competitive. While a further 45% are commercially available, but they will require a lot of further cost reductions through innovation and scale-up to become competitive. And you at L'Oréal are working full steam on transforming innovation at scale, at cost, and globally. I would love for you to share with the Assembly how you're working on making the production of your ingredients more sustainable. You talked about switching from petro to bio-based. You talked about circularity. Can you tell us a bit more about how you go into getting to scale?
Yes. And maybe just to take a step back here, one of the objectives that we have with regard to our upstream part of the value chain, the production of our ingredients, is that we aim at having 95% of our ingredients either bio-based from abundant minerals when it comes to inorganic compounds or from circular processes by 2030. In 2022, we were at 61%. So you can see there is a huge gap to bridge. So when we look at the upstream part of the value chain, let's just take the example of feedstock. One of the key questions for us is how can we promote the sustainable cultivation of feedstocks? Let's take rice as an example. So we are using in some of our L'Oréal professional products rice bran oil. And the rice is coming from Thailand, which is one of the major producers of rice globally. One of the main issues when cultivating rice is actually about the emission of methane. And so what we have put together with local partners is a demonstration facility in order to deploy regenerative agriculture practices. So basically, cessation of tilling, agroforestry. And by the way, agroforestry is actually good for the farmer because it diversifies their revenues. And the SRI, which is a system of rice intensification that basically both reduce methane emission but also reduce the use of water. So that's the type of activities that we are launching. We are also working with startups, with entrepreneurs. We set up together what we call the Green Sciences Incubator, which is basically a unique model by which we can collaborate with startups for 12 to 24 months in order to be able to demonstrate the proof of potential of their technology for the beauty industry. And in this respect, coming back to feedstock, we are, for example, working with a Belgian-based company called Botalis, that has developed an, I would say, biomimicry indoor farming. So basically, it's a type of controlled environmental agriculture, and we are assessing this in order to secure some of our specialty crops that are under threats, in particular when it comes to climate change.
Thank you. I really want to try to keep a bit of time for our questions, but there's so many topics we would love to cover. Jean, if you allow me to turn to you, first I would love to thank you deeply for remembering us that, or telling us how much science has proven true in the past, and telling us about your hope for how science can contribute in the future. At the same time, while you were saying so, you also talked about the importance of modifying the way we live, the way we consume, and you talked about science needing to connect with humanities for us to be able to succeed in the transition. Can you tell us a bit more about what you mean by that?
Yes, thank you, Sandra. Good evening. So I will build on my introduction. So our unit is a gigaton of equivalent CO2. We emit 60 gigaton of carbon, 60 million gigaton of carbon, 60 billion gigaton of carbon per year. Out of them, 45 of carbon dioxide. 80% of this carbon dioxide is due to our use of fossil fuels, the remaining part, deforestation, cement, and we had 12 to 15 gigaton of equivalent CO2 for other gas, methane, and nitrous oxide. So when we look at, and this exercise was done by IPCC in the last IPCC report, looking at what could be done between now and 2030 to be able to keep aligned with this objective of 1.5. We were not on this track, but this would have been possible. This is the message of IPCC. And I have when you look at what could be done between today and 2030, it's really a lot so a lot of things have been already evoked by, for example, is not far from 10 gigaton in renewable energy, so solar, winds, reduce, and also geothermal hydropower, 1 gigaton for nuclear, 1 gigaton for carbon storage, carbon capture and storage, and I will not go on or not, but we have also a lot from land, water, and food, and for example, obviously reduce deforestation can reach also 4 gigaton and so on. Carbon sequestration in agriculture, and obviously it's also in terms of industry, waste, settlement, and what I will not go in the detail of this, but in each objective you have to have innovation and science. This is clear for me. Okay, so this would have been possible. We are not on this track, but this was the message of the last IPCC report, and it's clear. But there is also another message I would like to give, and which is also, I agree because it's clear that the main conclusion of this IPCC report, transitioning from fossil fuel without carbon capture to very low or zero carbon energy sources, such as renewables, fossil fuel with carbon capture and storage, demand-side measures on improving efficiency, reducing non-CO2 greenhouse gas. Okay, so all these measures are well known, but again, they need a lot of science, and but also IPCC insists, and I really share this, on this demand-side strategy, which are categorized under avoid, shift, and improve, and they can reduce between 50 and 80% of emission across all sectors. This is clear. It's not only, I mean, it's really, we have to look at technology, at innovation, social, and so here they use the terms of socio-behavioral innovation, not only technological, but I mean, this is clear. I mean, innovation is technological. It's in also, and I am myself a chemist engineer, so I believe in the importance of catalysis, and you have a lot to do. It's clear in all this, and also obviously in terms of renewable energy or nuclear. So it's for the country who use nuclear energy. But it's important to keep in mind that, okay, so we will not succeed without thinking of organization of our society. This is the main message of IPCC, and okay, lifestyle change can rapidly deliver climate change mitigation. So we have to think about this also. It's a combination for me that we will succeed if we are able to combine innovation, research innovation, including technological innovation, but also really think about the organization of our society at large. This is my main message, yes.
Thank you, Jean. So, innovation through merging expertise, changing the way of researching and working, connecting fast with business, creating products and bringing them to scale at cost fast. Quite a lot of challenges. Would love to finish with you, Avner. You said you aspire not only to develop scalable technologies, but also impact the mindset of people. You have a group of highly motivated actors and builders of a transition in this room. What is your ask to us, to each of us?
Yes, so obviously I'm speaking in front of a very talented audience, and I'm sure that each and every one of you has a lot of power in your hand to make a change. So you asked me to address the audience, and so I'd like to address you by asking you to think how you use your power, your brain power, and everything you have with a mindset of sustainability, because that is by far and large the most immediate challenge that we face. I don't think I have to convince on that. And this challenge will not be solved by letting other people do it. I think each and every one of us has to be committed and engaged in being part of the solution. Now, this can be small, as you know, thinking when you buy something, whether you really need this, whether this thing comes from a source with more or less impact on the environment, and it can be very, very large, like changing your career. I can tell you from my own experience, I was educated as a physicist, and today, basically, my research is in electrochemistry. I couldn't believe that I would turn into a chemist or a sort of chemist when I studied physics more than 30 years ago, but here I am. And the sole reason why I made this shift is because I put the environment and the planet in front of me each and every day, hour by hour. And I think that if I can deliver this message to you, and from you to each and every one of the people you know, your worker, your friends, your colleagues, that is the way that sustainability mindset would change. Thank you.
Thank you. We have time for 2 or 3 questions. Valérie, you agree? Okay. If you can just introduce yourself. Thank you.
Yes, I can. Nadège Troussier. I was a researcher in sustainability science and especially in engineering design. And then no, I'm not doing this job, but I'm working to change engineering curricula at Arts et Métiers Science and Technology Institute. I have a question about your research, because much of you are researchers. We have the sustainability science shown that there are 2 very big aspects to develop science for sustainability, which are transdisciplinary. That means not only interdisciplinary, but also the way we involve society, social actors in research, and how we accelerate knowledge transfer to be able to adapt and then to be able to in crisis context, to be able to have local action, even if global value chain are not possible. So my question, I have 5 questions. So just one big one, which is, as it is mainly a social matter, how do you integrate human sciences in your research? And then how does it change the way you are doing research?
Alors, from the preparatory, I was going to ask you, Philippe, to answer. Is that okay?
Okay. So I'll give you two examples. Regarding, and I will take one on purpose because I think carbon capture and e-fuels and so on. So we've been doing that. I saw there is a demonstrator, and so we started a PhD working on the acceptability. So this solution is not now developed. It should be in a few months. So the leading scientist is just behind you, and so we started by working on the social aspects. So how do we work with end users of so people living in the campus to discuss how so this solution and to address the social technical feasibility of this project. So that's one, and second is regarding consumption. So demand mastering. So the concept of flexibility. So how do we make people move? So consume less or shift their consumption in a way that it's less demanding for them, so that it's easier for people to, so especially with when dealing with renewable energy production, so we have to adjust our consumption, and so the demand side is addressed in this way in the Energy for Climate Center.
Thank you. One more question. A tough question that sits between us and the cocktail. Thank you.
Hello. So I'm Maxime Dom. So I'm in a consulting company, but I'm a chemist on my own. I made the right choice at the beginning. So I have a question because the topic for tonight was science and innovation for a sustainable future. And there is this quite famous quote saying, research is turning money into knowledge, and innovation is turning knowledge into bills. And my question is, I would like to have your very short opinion across the table about how good or bad is the public support currently. Is it too much aimed at research, too much aimed at innovation, or is the equilibrium well? And what do you foresee as very important decision in a policy side, because it's strongly linked to social issues, as you mentioned. So yeah, regarding policy and supporting either on research or innovation, what's your opinion on that? And of course, the answer, both are necessary, is not acceptable. Thank you.
As it is a complex question, can I suggest we have one answer for Israel and one for France? Does it work? Who wants to take it for Israel?
So, I mean, there are many aspects to your question, and I will address one with your permission. So my 2 cents on this regarding policy and research and innovation, and I would like to address the research side. So we have seen in multiple funding sources, specifically in the EU funding, a transition from basic science. In FP7, the first program I was involved, there was a big component in basic science, TRL 1 to 3. So my entire first European project was TRL 1 to 3. Today, unfortunately, we cannot, at least I cannot, in the field I'm working in, I cannot find 1 to 3. It's all 4 to 7. And as a scientist, I cannot find myself there. And I think it is important to continue support of fundamental science. And that would be my 2 cents for your question.
So I have the same opinion. It's very important to continue to support basic research, fundamental research. I'm in a field myself which is really basic research, and try to understand our past climate change. So, but it can be very important for understanding climate, and it's only in pursuing basic research that we will succeed to create innovation. This is clear for me.
Oh, Olivier.
Just if I can add one thing in this respect. We used to think about innovation as trying to solve, one specific problem on the value chain, and I think we should consider the whole value chain. Coming back to what I was talking about the feedstock. Today, if you ask a farmer to switch from intensive agriculture to regenerative agriculture, he or she will not do it, because for 5 years, there's going to be a drop of performances, so a drop of revenue. After it comes back, and hopefully will be higher. And so I think we also need to think about the overall business model. We need to be innovative in the business model. How can all the players in the value chain can support the farmer to get there at the end of the day? And on the other side, there is a consumer awareness aspect as well. And I think we should also focus on how do we help the consumer to make the right choice. And so here we have to be very cautious because it does not to be partisan. So this kind of cross-industry endeavor, and we need to be really robust. So it needs to be science-based. And I would just finish with these examples. In the beauty industry, we have been funding with other competitors what we call the Eco Beauty Score Consortium, which is based as informing the consumers about the environmental impact and social impact of the products using a standardized method.
I think, Charlotte, you have also a view to share?
Maybe to give a different point of view, I'm a scientist, obviously, so I think science and technology and research is extremely important. But I also think that we have to be realistic and keep an eye on what we know. And we know, for example, that a breakthrough which is developed in the laboratory in energy, let's give an example, in order to make a 1% to have a 1% supply of the global energy, we need 15 years and trillions of US dollars, right? And we have less than, it's approximated, less than 5 years left on our carbon budget. So we know that whatever is going to make the huge change, it's not going to be a breakthrough. It has to be technology which already exists right now, or we're going to have a huge overshoot in the amount of CO2 emitted. So I would say it's extremely important what legislature does. Many things which already exist could become economically viable with the right legislature, and so it's really a team effort. Yeah.
Thank you, Charlotte. I love to have a woman conclude this panel, despite the fact that we had very esteemed male colleagues. Thank you very much for joining us. Thank you so much for the inspiring discussion. And Valérie, now to the next.
So we're going to go to the cocktail now. We're going to discover the startups that we selected. Merci à tous. Je vous invite à passer au cocktail. Je remercie nos brillants intervenants. Merci à Sandra. Merci au comité directeur du Technion France. Merci à l'équipe du Technion France, à Ambre et à Léava. Merci à Ariel, merci à Colette, merci à Gabriel, à Dorian, à toute l'équipe, au SPCJ. Et voilà, je vous invite à aller rencontrer nos startups et à boire un verre, échanger. Merci à tous. Merci à vous.